Okay, so you guys are going to ask me questions today, and then work on your note sheet. Okay? All right. So the first thing I'm going to go over is difference of two cubes. So TJ, let me know when you're ready.
Cube.
Okay, so we have x.
2 cube.
Yeah, x to the third minus 125.
One. That. Okay, can you repeat that equation? Sorry.
X to the third minus 125. So first step is make each term as a cube. Because is 125, can you make that into a cube term with a base raised to the third power?
Yeah.
So what is that?
5.
5 cubed, right?
Mm-hmm.
So then we rewrite as a cube. So then you get x cubed minus 5 cubed. So now it really is the difference of two cubes. Okay, so then this is when you get your form. So this is in the general case, they call it. And in most instances, this little form will work. And for our purposes, it will work. So x cubed minus 5 cubed. And the formula is open a minus b close open a squared plus ab plus b squared. Okay, so that's the form. And in our original expression, a cubed minus 5 cubed, x is our a term, and 5 is our b term, not the negative, just the plain old 5.
Why just the 5 though?
Because this is just a difference of cubes, so you're just taking your bases is all you're doing. You don't look at that negative sign.
Okay.
So then we just plug it in for each part of this general case expression. So we have a minus b. So remember, a is our x, 5 is our b term. So then you get x minus 5 in parentheses. So open, x minus 5 close open. And the second part is a squared plus ab plus b squared. So our a squared,
X squared.
it's a squared plus ab plus b squared. So remember, our a term is x, so then we dump that in for our a, so then we get x squared plus, and the next term is a times b, so we have x times 5,
Or 5x.
right? And then our last term is b squared, which is 5, so it'll be plus 25. So that's as far as you can factor this out. So you have open x minus 5 close, open x squared plus 5x plus 25.
Okay.
So that is factoring out a difference of 2 cubes.
I see how to do it. I can't say I understand it, but I can say I do it now.
It's just a formula you get to use to factor it out, instead of going through the whole rigmarole, which is pretty cool, because you're like, okay, I know the form, this is how it factors out. It saves you a lot of time. Because if you think about it, you're trying to take out and pull out as much as you can. So in order to understand it, let's boil it out and see what happens. So we have x minus 5 times x squared plus 5x plus 25. So what we get is, so x times x squared gives us our x cubed back. Then x times plus 5x gives us plus 5x squared. And then x times our 25 is plus 25x. And now we need to multiply through, that's negative 5. So then negative 5 times x squared gives us minus 5x squared. Negative 5 times plus 5x gives negative 25x, or minus 25x. And then minus 5 times 25 is what? Minus 125. So everything in the middle inside of, so we have x cubed. Now let's combine like terms. So we have 5x squared, and then we also have a minus 5x squared. So those drop out. And then we have a plus 25x and a minus 25x. Those drop out. So we're just left with x cubed minus 125, which is what we started with. So we factored an x minus 5 out of our original expression. And you can't factor out x squared plus 5x plus 25. You can't factor that out anymore. So that's why you leave that as it is. Does that help?
Okay.
Could
you like give me one so I can do it and see if I can do it right?
Sure. So just think of any cube. So x cubed minus 8.
Is that open to all of us or just TJ?
No, of course, it's open to everybody. So if we have x squared plus 12x plus 36, you set up your two sets of parentheses, factor out your first term, which is the first term in each one of your binomials. So factor that out. What do you have for your first term? X squared.
Right. See, I understand that. What I'm not understanding is the example they give here.
Yeah, and then I'll explain it to you as we go. I want you to just follow through with me on this, okay?
Okay.
So we have two sets of binomials. We break out this first term.
Right.
Okay? And we know it's x and x. So if we break apart this 36, what do we know about that? How do we do that?
Square it.
It's square. It's the square of what?
It's 6.
6, right? Okay. And look at our signs. We have pluses all over the place. Okay.
Right, so just be plus.
So we have x plus 6 times x plus 6. And I think the part that's confusing you is the 2ab.
Yeah, that'd be it.
So if we have x squared plus 12x plus 36, and we know it factors down to x plus 6 times x plus 6, which we can rewrite as x plus 6 squared, correct? That's the same thing?
Yep.
And so if we have x plus 6, the x is our a term. The 6 is our b term. And that middle term is 2 times ab. So our a term is 6. Our a term is x. Our b term is 6. That's 6x if we multiply it together. What happens when we multiply it by 2? 6x times 2.
12.
12x, and that was our middle term, right?
Yeah.
So we took the square root of our first term, we took the square root of our second term, and that gave us x plus 6. And then to get that middle term, it's 2 times that first term and the last term, which in this case was 6 and x. Does that make sense?
I guess so.
So try one. I want you to try one on your own and see if you can. So what if you were to try?
See, I understand it, like, when you throw numbers in, it's just that 2AB, it's like,
Right.
How do you get 2AB? What?
Basically, if you look at your first term and your last term, and they're perfect squares. So what if you have x squared plus 14x plus 49?
It's going to be x plus 7. Squared.
Exactly. See? And how did you figure that out? Because it's x plus 7 squared. You take the square root of this 49, which is 7, multiply it by 2, gives us our 14, times the x gives us 14x. So I think you understand it.
Yeah.
So here, let me give you one more, okay? And I want you to see if you can just quickly figure it out. What if you have x squared plus 16x plus 64?
X plus 8 squared.
Exactly. X plus 8 squared. So another one. What if you have x squared plus 18x plus 81?
X plus 9 squared.
Exactly.
Hey, can I answer one?
So what if you have x squared plus 20x plus 100?
X plus 10 squared.
I'll slap you.
Oh.
Another guy.
That's exactly
Answer it. I want to see if I get it.
Okay, so let's see here. What if you had, TJ, let Brian answer, x squared plus 22x plus 121.
Wait, did you just say 2 in the middle?
I
The middle factor is 2?
22. X squared plus 22 plus 121.
X plus 11 squared?
Yes.
Oh, right. Okay, I do get it. Okay. Cool.
Yep. Exactly. Okay, so I'm going to start that again. So synthetic division. Step 1. The divisor must be in x plus r format. So what that means is you cannot have a coefficient in front of the x of your divisor. And if it is, you have to divide everything in your problem by that coefficient. So if you have 2x plus 3 as your divisor, you have to divide everything by 2. Okay. Step 2. Put in descending order by exponents. X to the 4th plus x to the 3rd plus x to the 2nd plus x to the 1st plus your number, your integer, or whatever it is. And if you don't have a term, you have to put in a placeholder like 0x to the 2nd. Okay, that's step 2. And when you start doing your synthetic division, the number you're multiplying all of your coefficients by is the opposite of your r. So if you have x minus 2, you multiply through with a positive 2. All right. And then you bring down all of your coefficients and you multiply that r through each term. And remember, the last term is your remainder. So if it's a 0, you have no remainder. If it's a 1, then it's 1 over your divisor. So that's the rule. And then lastly, your 1 over your divisor needs to be your original divisor. So if you divided it by 2, you multiply the numerator and the denominator by 2. So you end up again with your original divisor. So let's go through an actual, honest-to-God example. So if we have something like, let's see here. Let's do, okay, y to the 3rd plus 3y to the 2nd minus 5y minus 4 all divided by y plus 4. Okay, so we have it in descending order. We have y to the 3rd, to the 2nd, to the 1st, and then the minus 4. And our divisor is y plus 4. So when we bring it down, we end up with the opposite of our integer in our divisor. So we end up with negative 4 vertical bar, or if you're doing it in Excel, negative 4 then one cell over, your coefficient. So we have y to the third, which is 1. The coefficient in the y to the second term is plus 3. So then we have a 3. The coefficient in our y to the first power term is a negative 5. So we pull down a negative 5. And our last is just a negative 4. Okay, and then you leave a space underneath all of these coefficients. And you bring down, you have your equal bar underneath, which in Excel you don't have to do the equal bar. You just go down a couple of cells or rows. Bring down your first coefficient, which is 1. Then this negative 4 from our divisor, we multiply to that negative 4 and put under our second coefficient. So we have negative 4 times 1 is negative 4. So we put that under the 3. 3 plus negative 4 gives us negative 1. We put it under our equal bar. So now we have 1 and a negative 1. So this negative 4 we then multiply to that negative 1 we just got. So negative 4 times negative 1 is positive 4. Now, and we put that underneath the negative 5. So negative 5 plus 4 is negative 1. Again, now we multiply that negative 4 times the negative 1, and that gives us positive 4. So then we subtract and we get 0. So we have no remainder. And then when we write this back with all of our variables and our exponents, we go 1 power less than we started with. So we started with a y cubed. So then we get y to the second, because it's a positive 1, y to the second minus y minus 1, because our terms were 1, minus 1, and minus 1, and you go in descending order. So y cubed plus 3y squared minus 5y minus 4, all divided by y plus 4, gives us y squared minus y minus 1.